What is model in machine learning? Many newcomers in the field are searching for this on YouTube. Let's try to understand about model in machine learning with some simple examples. Let's try to go step by step and try to understand about model in machine learning. Okay. So if you have some context of what is machine learning, then good. If you don't have any context of machine learning, right, then let us try to understand what is machine learning itself. Okay. So I will write here machine learning, and we will define what is machine learning first. So machine learning is basically a process in which machine or any computer or system learns the pattern. Okay, so I will write here what is machine learning. Machine, okay, machine learns, okay, the pattern using. So for learning the pattern, machine needs something, right? So I will say here using dash and dash. Okay. And I will say here and produces. Okay. And produces dash. So how many blanks I have here? 3 blanks. 1, 2, and 3. Okay. If you understand what should go in these 3 places, right, then you will be very clear on what is machine learning. Okay. So let's try to understand with a real world example. Suppose I give you size of the house. So you can think of a 2-bedroom flat in India. Okay. So size of the house, and here I will say cost of the house. Okay. Cost of house. So in this data, I have 2 columns. What are my 2 columns? Column is size of the house and cost of the house. So in this, I can have many records. For example, first record, I can have, let's say 1200 square feet house. Price could be, let's say 80 lakhs. Then there could be 1400 square feet house. Price could be, let's say 90 lakhs and things like that. Okay. This is my data. So if I want machine to learn the pattern hidden in this data, if I want machine to learn the pattern hidden in this data, then the first thing that I need to supply to machine is data, and that comes here. Okay. So machine learning learns the pattern using what is the first thing, what is the first prerequisite? Data. Machine will need some data to learn the pattern. Okay. That is the part 1. Part 2 is once you have given this data to the machine, right? Then you also have to tell to machine what should be the approach of learning the pattern. So there could be n number of approaches to learn the pattern. Out of those n number of approaches, right, whatever approach you use, that is called algorithm for that particular learning. Okay. So that becomes your second block here, or second empty space here. Okay. So machine is learning the pattern using data and algorithm. And now comes the most important and critical thing here. So till here, till this red box, machine has learned the pattern. Okay. Till here, machine has learned the pattern. Now what? Now what should happen is, once the pattern has been learned using this data, right? If I ask to machine, hey, there is a 2-bedroom house, which size is 1350. Can you tell me what would be the cost of this house? So from the learned pattern, machine should be able to tell me, I have learned the pattern from the previous data that you gave me, and I can tell you that the price of 1350 square feet house should be 85 lakhs. So this 85 lakhs Indian rupees should come from machine learned entity. Okay. So when machine has learned the pattern using data and algorithm, it produces something known as MODEL model. And you can go and ask your questions to this model. What you can do, you can go and ask your questions to the model. You can say that, hey model, tell me 1350 is my size of the house, what will be the price. You can go and ask to the model, hey model, can you tell me if 1500 is the size of the house, then what would be the cost of the house? And you can tell to the model, hey model, if 1600 is the size of the house, then what would be the price of the house? You can ask as many questions you want to the model. Why? Because model is the entity that has learned the pattern from the data using algorithms. I will repeat it one more time. What is model? Model is basically the entity which has learned the pattern of the data. Once model has learned the pattern of the data, you can ask questions to the model. Okay. In the same regard, you would be encountering concepts like model selection. So which type of model you want to use? There are different types of models. Okay. You might be hearing terms like model optimization. Okay. Optimization. All these are different processes to make your model good. Okay. And then you would be hearing the terms like model deployment. All these are different terms to work with your model. Let's go ahead in Python and try to get some feel of how the model selection, model optimization, first of all, model building happens. Okay. So I'm taking you to my uh, Visual Studio here, and I'm trying to show you a simple model here. So remember, what is model? Model is basically an entity that has learned the pattern from the data. So what are the few things we will need? We will need data to create a model, right? We will need data, we will need algorithm, and then we can get a model. So what I'm trying to do here in my code is I'm trying to create a data here. So I'm importing some packages here, import numpy, import matplotlib for plotting, and from sklearn.linear model, I'm importing linear regression as one of the library. Okay. From line number 5 to 7, what I'm doing is I'm simply creating some data. So if you see here, just like I gave you example here, size of the house and cost of the house. Okay. So in X, I'm defining some sizes of the house, 500, 750, 1000, 1250, 1500. Okay. And this reshape is basically when you have only one feature just to format the data basically. And Y is basically price of the house. For example, 150, 200, 250, 300, 350. This could be in hundreds of US dollars. Okay. So don't confuse on that. Okay. 150 means 150K USD. So this is basically two columns here that I showed you, size of the house and cost of the house. Size of the house is these values. Cost of the house is these values. Okay. Now we have the data and we have the algorithm, linear regression. We have two things now. So line number 3, we have imported the algorithm. Line number 6, 7, we have the data. Now we are ready to create our model. That is what we are doing in line number 10. We are saying, give me a linear regression model. Okay. This is just the initialization part. And then line number 11, we are saying model.fit xy. At the moment you say model.fit, what you are saying to the system is learn the pattern hidden in x, x, and y. Okay. At the moment you say model.fit, what you are doing basically is you are giving data and algorithm, and you are asking the system to give you a model. So X and Y is your data, linear regression is your algorithm. Okay. So this is your algorithm, this is your algorithm, and X and Y are your data. Using these two things, you are generating a model. Okay. Once you have the model, as I told you, you can make prediction. Now to this model, I can simply give values and I can get the output. So in this case, model is predicting again on X itself, but we can give some values also. I will show you that as well. But if I run this right, I will show you something interesting here. If I run this thing right, you will see that it will simply run this and create a beautiful chart here. That chart is important. I want to show you that. If you see this chart right, what is happening here is what is happening here is on x-axis you have size of the house, on y-axis you have price of the house. Okay, these blue lines, right? Sorry, blue dots are the actual values, and the red line is the predicted value. So actual values means these values. Okay, these values. And predicted value means whatever is the output of y pred. So if I go and print y pred, right, you will see that same values will get printed: 150, 200, 250, 300, 350. In this scenario, right, actual and predicted are always same, which is not a real world scenario normally, but in this scenario, for example purpose, actual and predicted are always same. So these blue dots are your actual values and red line is your predicted value. Okay, and where from these predicted values are coming? This is coming from the model. Okay, so line number 14, prediction is happening. I will simply tell here prediction is happening here. Okay, which means that if you go to your notes, right, these predictions, right, model is saying 85 lakhs or 90 lakhs or 100 whatever, right, these predictions are happening in line number 14. Okay, and then it is just the plot, so don't bother much about the plotting part. Plotting is just about seeing that in the chart. Okay, so what I'm going to do now is I'm going to stop this and I'm going to show you why pred, right, why pred. Let me remove this part for some time. Why pred will be exactly same as what is there on the top, that is why, and that is the reason, right, that is the reason you will see that it is always on the same line. So let me show you. So it is running now. If you see, right, 150, 200, 250, 300, 350, this is your y pred, and this is what is y also. That is the reason when we were plotting, right, we were seeing that both of these things are on the same position. Okay, this is about simple model, one simple model we built now, and we have done the prediction. One important thing to understand here is, depending on the situation, there could be different types of model. For example, in this is a linear regression model, right? Linear regression model helps you to solve regression problems. Similarly, there could be a logistic regression model. Same problem statement here, just that we are trying to predict a categorical feature. Okay, and this is a logistic regression model. So this is also a model, but this is a logistic regression model. Okay, so what I'm doing here, I'm just importing logistic regression. I'm just importing a different data set. I'm breaking this into test and train, and I'm creating a logistic regression model this time. Okay, so depending on the situation, you will create different types of models. So if you want to understand more about these, right, what you have to do is you have to go to YouTube and search for unfold data science, unfold data science plus your topic name. So for example, now I'm talking logistic regression. Okay, so you simply say logistic regression. Before that, I was talking about linear regression, right? So you can simply say unfold data science linear regression. And now I will talk about some other concepts. You can simply keep searching like this. You will get detailed videos on all these topics. Okay. So coming back to our lecture here. So here we are trying to understand types of models. So depending on situation, you will create different types of models. That is a model. Now saving and loading model is an important thing here. Once we have built a model, right, we can do is we can dump that model in our hard disk just like any other file. Okay, and we can load it. So there is a package called joblib. You can simply joblib.dump, you can dump your model, and joblib.load, you can load your model back to make the prediction. So let me copy this and put it in the same file where I was showing you a simple model. Okay, so here I will go and I will just put it. So what I'm doing, I'm just importing joblib. I'm saying save the model in the hard disk, and here I'm loading the model. Okay, so I will say here loaded model, just loaded model. Okay, what loaded model is basically the same model, but this time it will read from the disk. So let me try to rerun this one more time. Let me save this and rerun, and you will see that the model will get loaded and here one file will get written. Okay, so if you see here, model.joblib file is written in my disk. Okay, and what I can do now is I can do the prediction using loaded model as well. So previously I was doing prediction uh, using model.predict, right? X. Now I can do the same thing using loaded model as well. So let me try doing this. New prediction is equal to, okay, I will not take the original model, rather I will take the loaded model. Okay, and then I will print. So when I print that, what I expect is my prediction should be same as the original model's prediction. Okay, so let me try doing this. And if you can see, right, it is predicting the same results that we saw when we plotted the chart. So what I'm trying to show you from here is models can be kept in the hard disk, can be reloaded and used. Okay, that is one another aspect of model. One more aspect of model I want you to understand is basically model selection. So whenever we build any model, right, we do not know if the model is good and fit for the purpose or what is the best model for me. Model optimization is concept on the similar lines where we try to find the same, optimal model for any given scenario. Okay, so if you see here, what I'm doing here is I'm using something known as grid search CV. Okay, and please remember guys, I have created detailed video on all these topics. You simply have to go and search grid search CV unfold data science. You will get a video explaining you all the concepts of what happens in grid search CV, but I'm just trying to tell you at a very high level. What it does is it gives you the best model from a set of parameters. So it basically tunes the parameters, hyperparameters of your model. Okay, so if I take this, right, if I take this and if I put in my logistic regression model here, if I put in my logistic regression models here, right, then what I'm going to get is I'm going to get my best model. So what I'm saying is my C value is this and my solver is this. These are basically two parameters of the model. I'm saying please optimize these parameters for me. Okay, and what is going to happen is it is going to give me the best parameters now. So what I'm trying to do using grid search CV is give me out of C 0.1, 1, 10, 100. What is the best C? It is telling me 1 is the best C. Okay, if you pay attention here, I have given 4 possibilities: 0.1, 1, 10, 100. I have given 2 possibilities for solver: LBFGS or liblinear. It is telling me you go ahead with C1 and solver LBGFS. This is the best hyperparameters for you. Okay, this process is called model hyperparameter tuning, and from this you can get the optimized model. So just another concept to learn from the model point of view. Okay, and when we talk of model optimization, similar kind of concepts will come, and the more you go deeper into the technical aspects of the model, right, one another important concept from the model point of view is called model deployment. Okay, I can very well cover this, but again I will request you go and either you can go here and search unfold data science model deployment. Okay, you will get a detailed video on this topic. Or if you want to learn it more systematically step by step, if you are a beginner, you want to learn it more systematically step by step. For example, this is my course on unfolddata-science.com. If you go here, right, you will know everything right from introduction to data science to Python for data science, okay, to statistics for data science to SQL to machine learning to model deployment to how to create your resume, etc. So I'm covering everything end to end, keeping in mind how it will look like for a beginner or for a newcomer in the field. Okay, so please consider having a look at unfolddata-science.com and on this course. Okay, meanwhile, topics that we have learned today is basically very simple but important things. What is machine learning? What is model in machine learning? What is meant by model selection, model optimization? What is meant by model deployment? How different types of models can be used, and what are the scenarios in which model can be dumped, model can be reused, and things like that. Okay, please give me a thumbs up if you like this video, guys. I'll see you all in the next video. Wherever you are, stay safe and take care.